So let's see what happens when we change from addition of polynomials to subtraction. So subtraction is going to change the sign of every term after it. Think of it as distributing a negative sign to each term in the second parentheses. So again, I notice that I have a positive 1 before the first parentheses, so I know that every term inside is not going to change sign or value. But I notice that I have a subtraction sign that I'm going to have to distribute to every term in the second parentheses, and that means I'm going to have to change their sign. So when I write this 7x down here, I'm going to have to distribute that negative with it. So it's going to become minus 7x. It's going to become negative. Now look at the 4x squared. If it's positive, what is it going to be when the sign changes, when that negative is distributed? Well, it is also going to change to a negative 4x squared. Okay, and now I'm back to where I started with my adding polynomials. Now I'm going to combine like terms, so I'm going to start looking for my highest degree, and that is a 2. My highest exponent is a 2. So I have 2 terms with x squared. And remember, this is a 1. So what do I get when I combine a 1 and a negative 4? I'm going to get a negative 3x squared. The next highest exponent I'm going to look for x terms. And I see one right here. I have negative 7 of them. That is my only x term, so I'm going to write negative 7x and my final answer. And now I'm going to look for constants, because that would be the next thing I'm looking for. And I see I have a constant right here. I have a negative 8. Because that is my only constant, I'm just going to copy that also down into my final answer, and I ended up with the trinomial negative 3 times the value of x squared minus 7x minus 8. So really, adding and subtracting are so similar. The only difference is you have to remember to change the sign of every term in the second parentheses before you start combining like terms. And that just ensures that all of these terms get subtracted. Most students distribute that first subtraction sign, so they would make the 7x negative, but then they would leave the 4x squared positive, and that's not going to get you the correct answer. So let's try another example. Again, I see that I have a positive 1 in front of the parentheses, so I know that the terms in the first parentheses are not going to change value or sign, so I'm going to recopy them down. I see that I have a subtraction sign here, which is telling me that I'm going to distribute my negative sign to every term in the second parentheses. So I'm going to write them down now. When 2x squared, distributing that negative just means that it's having a sign change. So it's going to become a minus 2x squared because it's going to change to a negative. This negative x is going to have a sign change because it's minus a negative. It's going to change to addition, so that x is now positive. And the same thing with the negative 4. When I distribute that negative sign, it's going to be minus a negative 4, which means now I'm adding because that 4 has become positive. And again, I'm going to pick up right where I left off with adding. I'm going to start combining like terms. I'm starting with the biggest exponent number, which is my x squared terms. So I have 2 of them. I have 3x squareds here, and I have a negative 2x squared here for a total of 1x squared. And again, you will not see that 1 in the final answer. I'm just writing it for your notes purposes. After the power of 2 comes the power of 1. So I have an x to the power of 1 term here. And I also have 1 here, and that tells me I have 1 of them. So I have negative 5 over here and 1, and when I combine them, that's going to give me a total of negative 4x. And now I'm going to have my constants. So I have 3 here and 4 here for a total of 7. And that's how you take care of subtraction. So let's look at how might they ask me about adding and subtracting polynomials when I have a shape involved. So we are going to write an expression for the perimeter of the given polygon. So remember, an expression is telling me that I may have letters in my final answer. So I may not get an actual number answer. And perimeter, remember, perimeter is telling me to add all sides. I now know what operation I'm going to be using on my polynomials. It's going to be the operation of addition. So here's what we're going to do. So if if we are adding, we really don't need those parentheses. The parentheses are really important for subtraction because we have to remember to distribute that negative. So I can, if I'm adding polynomials, I can just start looking for my terms with the highest exponent number. And that would be x to the third. Well, I have one here, there's 2. I have another x to the third term here, 4. And then I have an x to the third term here. And when I add up 2 plus 4 plus 6, I get 12x to the third. My next exponent I would be looking for is x squared. So if I look at all three sides, I notice I don't have any x squared terms, so I could write plus 0x squared, but I don't need to. It's not going to show up in my final answer. So now I'm moving on to my x terms. And I have an x term here, there's 6 of them. I have an x term here, there's -5. And I have an x term here, there's 1. So what do I get when I combine 6 plus 1 minus 5? I get 2x. So plus 2x because it's positive. And this is my expression for the perimeter. This is what I get when I add all the terms together for all three sides of my triangle. I get a perimeter of 12 times the value of x cubed plus 2 times the value of x. All right, moving on. Now I'm over here at this quadrilateral, and again, I want to find an expression for the perimeter, so I have to add all the sides up. Well, what do these little dashes mean right here? Hopefully you remember that it means that these two sides are the same. So this side is 3x to the power of 2 plus 2 times x plus 1, which means this side is also 3 times the value of x squared plus 2 times the value of x plus 1. So now I'm going to do just like I did over here. I'm going to start with my highest exponent, and I'm going to start identifying all of those. Well, I see I have a power of 3 here. I have no power of 3 here, I have no power of 3 here, I have no power of 3 here. So I only have one term with x to the third, and there are 4 of them, so it's going to be 4x to the third power. And now I'm going to decrease. Now I'm going to start looking for my x squared terms, x to the power of 2. Well, I don't have any on the top base, but I do have 3 on the right side. I do not have any x squareds on the bottom base, but I do have 3 x squareds on the left. So when I add 3 and 3, that's going to give me a total of 6x squared. Now I'm going to look for my x terms. And I have 3 on the top, I have 2 on the right side, I have 4 on the bottom, and I have 2 on the left. So when I add 2 plus 3 plus 2 plus 4, I get a total of 11x. Now, I want to remind everyone, when you notice you have two sides that are the same, that have the same markings, please make sure you fill in that side, because if you don't, you may forget to combine these terms over here because you didn't write them down, and that means your final perimeter expression is going to be incorrect because you are missing some terms. Okay? Now we're going to follow this up with our constants. So I have -2, 1, 3, and 1. Okay, so what do I get when I add 1 plus 3 plus 1 minus 2? I get 3. And again, please check your mental math in your calculator if you cannot add and subtract integers correctly. All right, well, if you can go forward with perimeter, surely you should be able to work backwards. So let's see what happens when I ask you to find the missing side. So we are looking for this side right here, and I have actually given you the answer for the perimeter. So I've said, okay, when you add all three sides of this triangle up, this is what you're going to get as your result. So the first thing we're going to do is we are going to add what sides we have together, because I want to see how much of my perimeter do I already have, okay? So we're going to look for the highest exponent number. So I notice I have x to the third. I have 2 of them here. I don't have any x to the third here. So I have 2x to the third. My next exponent would be x squared. So I have 2x squareds here, and I have 1x squared here for a total of 3x squared. And then I have an x term, because that would be the next exponent I would look for, x to the power of 1. I have -4x's there, and I have 7x's here for a total of 3x, so plus 3x. And now I'm going to add my constant. So I've got a -8 on the base, and a positive 6 on the hypotenuse for a total of negative 2. Okay, so now we've got this expression for part of my perimeter and this expression for the total perimeter. So let's think. I'm either going to add these two expressions together or subtract. And hopefully you said subtraction. Well, remember, for subtraction, we are going to need two sets of parentheses. You have to have parentheses with subtraction because you want to make sure that you do not forget to distribute that negative to the second parentheses. If you don't write parentheses with subtraction, you're going to forget that every term in the second parentheses has a sign change. So we're going to fill in the perimeter in the first parentheses. So 2x to the third plus 4x squared plus 6x plus 3. I had to write small to fit that in. And then we're going to take away what we have of the perimeter so far, which we have a combined perimeter so far with just those two sides of 2x to the third plus 3x squared plus 3x minus 2. Okay, so again, I see that I have some subtraction, so I cannot forget to distribute that negative sign and change the sign of every term in the second parentheses. Since this is a positive 1, I know that every value and sign is not going to change. So I'm going to have 2x to the third plus 4x squared plus 6x plus 3. Okay, so now I'm going to start writing the second parentheses. So if I distribute a negative, that is going to mean that this positive 2x to the third is going to become negative 2x to the third. If I subtract a 3x squared, that's going to become minus 3x squared because it's going to become negative. If I subtract and distribute that negative to the 3x, it's going to become minus 3x because it's now negative. And if I distribute that negative to a negative 2, it's going to now become plus 2 because that 2 is now going to become positive. And I'm back where I started with addition and adding polynomials. Now I'm looking for the largest exponent number, the highest degree, so that I can combine my like terms. So I see I have x to the third power, and I have an x to the third power here. And when I combine 2 minus 2, I get 0x to the third. Now I'm going to look for my next highest exponent, which is going to be x squared. So I've got 4x squared. And then I have a negative 3x squared here. So when I combine 4 minus 3, I get 1x squared. And now I'm going to look for my x terms. I have 6 here and a negative 3 here for a total of 3x. And now I'm looking for my constants. I have 3 plus 2 for a combined constant of 5. Okay, so now I'm going to clean this up because I want to be able to give my final answer for the missing side. So if I have a 0, so if my like terms combine to get 0, you know that you are not going to see that in your final answer. So if that's gone, now I have 1x squared plus 3x plus 5. Well, you know you're not going to see that 1 in the final answer, so it's just going to become x squared plus 3x plus 5. And that is your final answer. You have 2 practice pages of problems. One is specifically where I give you the problem for addition or subtraction, and then the second page is where you have to find the perimeter on one side, and then on the back you are trying to find the missing side of the polygon, the shape that you are given.